what we are going to talk about. So thank you everyone for coming here to see us talk about Ruby, the enterprise, and how we have rocked the world of the enterprise for the last 4 years. It's kind of weird that we are going to talk about enterprise and Ruby in the same breath, but we'll mostly share our experiences of doing Ruby on a very large scale project over the past 4 years. So I'm Sudhindra, and I have been working with ThoughtWorks for about 5.5 years, and I have done Ruby for about 4 years, starting 2005. And I have worked on various sizes of projects, and the one we are going to talk about is the most recent one I worked on.
Good morning, everyone. Thank you for coming. My name is Munjal Budhabhatti, and I've been working for ThoughtWorks for the last 4 years. So today's presentation is Ruby in the enterprise. It's more of an oxymoron, especially when you hear someone talking about Ruby and enterprise. So let's try to understand, what do we understand as an enterprise software? So enterprise software is a system that is used to support a business and its growth. So typical enterprise would have different stakeholders. So you would have typically inventory, sales, and marketing.
And in this, we are going to focus on our project that we did with Rackspace. As you know, Rackspace is the largest web hosting company based in the US. They have data centers all over the US, as well as outside in London, Singapore, and many other places. So a little bit of what we are going to cover. So we are going to talk about a little bit, give you a little background on what enterprise we are dealing with, especially Rackspace as a web hosting company. So basically, we're going to talk about what data centers are and what they contain, what are the challenges, what kind of technology decisions you need to make when you are trying to do these kinds of projects, what kind of architecture decisions you would have to make, how and what are the challenges in integrating with the enterprise, as we call it. And then we'll also talk a little bit about what kind of open source contributions we have been able to do over the last 4 years, and we will still continue to do that.
So understanding the problem domain in a data center. So typically a data center contains a bunch of servers, and it has networking gear such as firewalls, switches, load balancers, and so on and so forth. Now typically when you see, let's say, a client has a server at Rackspace or in a data center, and it has some issues with a server. So you want to quickly find out what's the location of the server. Could be another problem would be, in a problem domain would be, you want to find what's power efficiency or power specification of a typical server. If Rackspace is known for its support, and you want to find out as a company quickly what's the base problem. Also, Rackspace doesn't want to put, it's one of the best data center expert for a trivial problem. There are other problems in a data center would be you want to bill the client for the bandwidth usage. So these are typical problems that you see in a domain, and to address these concerns, we are going to talk about 3 key applications. First is IP automation. If you see, IP automation software has a complicated algorithms, because IP space in IPv6 is very limited because of 32-bit addressing. There are also other things that IP automation supports, are such as, let's say you are a customer, you are a startup, you started at Rackspace today, and within 6 months you really grew, and instead of just having a bunch of servers, you want to have like 20, 25, 50 servers. So migrating your data and your servers into a bigger network is a quite complicated challenge. A customer might also be, customer servers might also be present in different networks, such as private, public, backup, etc. And these are like the key challenges which are supported with IP automation. Recently, we have been also working on IPv6. If you see, IPv6 itself is quite complicated. A typical example would be on your MySQL database, you don't have any native IPv6 data types. So whenever you try to store such information, there is always a data translation.
Another aspect of dealing with data centers is actually managing all their networks. So what happens typically is a server, a usual Rackspace server that you buy, may be connected to up to 5 networks. Like it would be connected to a public network where all your traffic would be. They will also assign you a private network so that you can sort of administer, update your application and things like that. There will be a backup network which is totally independent, which is highly redundant. And there will be also servicing that Rackspace itself would be doing on your server. So up to 4 or 5 networks would be easily connected to your machine. So with all these networks, they have different IPs. They are allocated from different IP blocks. And what becomes a challenge is actually managing the DNS entries for this. The DNS database keeps on growing as you add servers to a database and as you add networks. So one of the challenges is actually to build an application that will be able to manage this amount of data. So a typical DNS server, DNS application when we launched it for a data center could start with a few million records on day one, and then it keeps on growing. The other challenge is actually maintaining an up-to-date cache so that you do proper routing. There are other legal implications on that, making sure that your DNS is up to date so that also secure enough so that your traffic doesn't get rerouted to some other competitor, for example. And the most key aspect of this application is that it has to be always on. You cannot run a data center with the DNS application down, right? So but the other thing you have to do when you're developing these applications is to deploy to production. So you have a very tiny window, actually, which is like 0 minutes to be able to deploy this. So you have to ensure that there is data consistency between deployments and all that. So that is another key concern when you design such a system.
The third application, which is Network Device Manager, I really love this application. It's a Ruby DSL for network devices such as firewalls, switches. What it does is it allows you to execute commands on network devices. Now, once you execute these commands, you get the output, and NDM, so as we call, allows you to scrape the data, and on top of that, it allows you to execute another Ruby script. Some of the key things that NDM supports is conditional and for loops, and it allows you to configure, diagnose, and get the status of a network device. It has a very intelligent command chain, which is configurable to build command structure to support various platforms, various hardware, and OS combinations. It is also used for debugging support, especially logging and all.
So just after giving you a glimpse of what are the challenges, just discussing these 3 applications, you see that each of them is independent in terms of what is their key requirement. So for example, IP automation, the algorithm has to be really fast and there should be no duplicates. DNS, you have to manage a huge database. NDM, you have to be able to actually write DSLs so that the network engineers can write chain scripts and run long jobs to find out the health of the network. So our challenge was actually picking up the right technology so that we can meet all these kind of various issues that we have to be able to support. So I mean, Ruby was an obvious choice given that it had such a good marketing value, that is, you can push things to market really fast. Also, ThoughtWorks itself and Rackspace, our client, both had enough expertise to actually support Ruby. What we had also found out is with Rails and its excellent web dev capability, that it was really easy to bring people up to speed if they are new. So building the team was really simple. And we were very excited about this, picking Ruby and getting to do cool things with it. But we had to prove that Ruby is the right technology. So what we actually started up with was the IP automation project. and we built a custom version of it for the client. And what we ended up having was build the product in about 40% of the cost as compared to an off-the-shelf product. Although the off-the-shelf product had many more features, the customer actually had really specific requirements of how they are going to manage IPs. Like you can imagine, there are regulations about how to manage IPs, and then there are best practices that are developed in that industry. So this needs to be able to support it. So we actually proved that Ruby could be used to deliver such applications quickly and make sure that Rackspace still has the competitive edge.
So if you see, we've been at Rackspace delivering continuously for 4 years. So how have you been so successful? One is the core disciplines, that you have a very focused user base. So your subject matter experts typically know what key aspects they want, but there are also times what they want and what we understand, they may not be in sync. So we always use a faster feedback, and it allows us to fail fast. Other key aspect what we have done is over the history of these 4 years, we always had more than 90% of code coverage. Now, there are a lot of people, they would think that, hey, let's not stick onto the number, but at times, ensuring that you have some amount of code coverage does help, especially when you have a new developer joining in, and maybe he or she doesn't really understand, and you really want to understand that, hey, this is a problem that was created, and you get a feedback faster. We just didn't refactor the code, because a lot of times you say, okay, over time, there is a developer that, and you need to refactor the code. But in addition to refactoring code, we refactor the architecture itself. So we evolve the architecture from a monolithic, huge application to a smaller REST-enabled application.
And I know we are throwing a lot of information here, but let's just go into a little bit of depth of how we ended up with the architecture that we have currently at Rackspace. So when we started, after the IP automation project, we started looking at their other business areas, and we said, okay, let's build an application that models a data center, and everything that the data center models will be in this application. We called it the physical space. So you could actually virtually track every server, its location, which network it is connected to. So there are two different worlds that we try to put in. The physical world, meaning this server is connected via this wire on this network, and also the virtual world, where there are all these networks that it is connected to, and there is routing going on. What we found out after having built this application is that not all the users are using all the features of this application all the time, and it was really hard, given the distributed nature of Rackspace, to get in all the data and populate this application. So that's when we went back to the drawing board and said, okay, let's see how we can make this usable for the user. And that's when we came up with, we rejigged the domain abstractions a little bit, figured out who is the focus group for a particular area of the Rackspace business. For example, somebody who's sitting in a data center is more interested in how many servers he has and where they are located and where a certain client is, as opposed to what network they're connected to. That is somebody else's problem. And so there were concerns that were not intersecting at all. So we actually separated these applications into individual applications. So this is the sort of the architecture that we had. We call these REST engines. So basically you build an engine that supports some REST calls for certain models or certain areas of the business. Those REST APIs can be consumed by anyone. You can write your own consumer that will give you data based on what kind of request is. Again, you need to be authorized to do that, meaning not just any employee from Rackspace can do it. Plus, we also built applications that were focused to these consumer groups, user groups, who would be using that specific sliver of the domain most of the time. While doing this, we also wrote some of the framework which will help us do that. So to speed up writing these RESTful apps, we wrote Resourceful, which we'll talk about a little more in detail, and to test these all together to make sure that IP automation works with DNS, and so on and so forth, we had to design a distributed testing system, and we'll come to that too. Towards the later part, what we figured was that there are these small domain parts which are only need to be written by one user. So, for example, somebody from inventory says, "Okay, I have bought 200 servers, so just load them into the database," and they are the only ones allowed to write to it. Everyone else just wants to know how many those servers are, what their IDs are, etc. So imagine that the green database is the one that has the server information. So the other apps, all that they need to do is read those models, and read what they have. So we wrote this pluginized model kind of a plugin, and what it does is basically you just create a Rails app and stick it in a plugin folder, and we just load it in the host application, as we call it. And the host application can then read this data from another database. So basically what this helped us is actually have very small applications, and still help us develop them to accommodate all kinds of user groups. Plus it reduced the maintenance that we are doing. So since these models are separated in their own world, so when we work on them, it's just we are working on that focused area and building that.
So you may be wondering, we have been just talking all these cool features, but again, integrating with enterprise is not that cool, right? You need comprehensive reporting. There are different departments in Rackspace which needs data. So usual thing when a data warehouse comes in, they tell you, hey, tell us what is your database look like, and we are going to extract all the data. That's not what we allowed. Again, as Sudhindra just mentioned, we have RESTful services. So even when you want to extract data, it is just allowed through RESTful services. This allows us to be independent from other departments. Another aspect what we talked about was just having very fine-grained RESTful calls. But there are times that you want to have, as you can see it in example over here, you have IP, NDM, environment, etc. But there are times that you want to have a core API which enables you to orchestrate the RESTful services to give a rich behavior. So a typical example would be, let's say I want to provision a server. Now that's a very rich feature. There could be granular services. For example, in IP, you go and assign an IP. You have NDM task, which creates a route, etc. And then you have DNS entries. So some of the key aspects of integrating with the enterprise, such as workflow engine and enterprise messaging system, I'll just cover. So we have used Root, which is a DSL-based workflow engine. So if you see, we've been talking about all these small applications, and there were times, these were written over time, and as Rackspace evolved, a network engineer used to go to different applications and would execute some commands, make a note of it on a piece of paper, and would go to another application and execute some more commands. So if you see, it would take a lot of time. There were times that a network engineer would touch about 9 systems to provision a server, and it used to take 4.5 days. Yeah, I mean, that's awful amount of time to just kickstart a server, or provision a server. Now, so we started something called as a one-click connection, and we used Route, which is a workflow engine, which orchestrates all of these things, and then we reduced this time down to 18 minutes. Now, just look at it, 4.5 days to 18 minutes. Now, this is one of the key enterprise feature. Another part which we have used was enterprise message system. We have used RabbitMQ. It's a highly reliable, available, and scalable EMS. And it allowed us to decouple our system for external system, such as core, cloud, etc. It also allowed us to decouple our processes, our deployment process, the methodology that we follow, because this is independent. Now, we can have different releases at different times. If you see, typically we had release every 2 weeks. And other part was distributed transactions.
Yeah. So as you will see, we had to look at a different amount of different kinds of functionality from different aspects of Ruby, and we had to look to find the correct libraries. And Ruby being such a wide community, there was actually something available. If not out of the box, there was inspiration out there. So you can look at something and say, oh, this is what I want, but I just need to change these parts of it. One of them being REST. So you could do RESTful stuff with Rails, but then we needed to change a little bit of internals of it. So we wrote applications that were sort of inspired by what is available out there, and because it was so easy since it was Ruby. So we'll talk about some of the applications that we have open sourced and available out there. So one of them is called Resourceful. What it allows you to do is write these REST engines very fast, meaning just if you have standard models and they have standard behavior like CRUD, and there is no relationship management or there is no complicated relations that need to be managed, they are available out of the box. The other thing that Resourceful allowed you is to do queries on models based on different columns. So usually you would be able to do find by ID, but Resourceful allowed you to do find by name, address, city, state for a person, for example. And so it is as simple as adding Resourceful to your project as a plugin, and then just saying this model is going to be accessible by or queryable by these many columns. And that's it. It allows you to write your app and exposes all the RESTful stuff. Yeah, behaviors. Another interesting problem we had was we were building all these applications and they needed to work together, like Munjal explained. They needed to work together to maintain data consistency and make sure that the server is provisioned at the end of the cycle. To make sure that we were able to integrate these, what we had to do is write consumer applications that would fire these REST services and get data. So our typical testing cycle would be fire this engine, fire the other engine, fire the third engine, fire the app, and then make sure that all these engines have consistent data. So to make sure that we can do this repetitively, we built a system called black box integration. So all these applications are treated as black box, and you try to integrate them. All you have to do is add that as a plugin in your application, and then it becomes integration enabled. And then it allows you, since it's all DRB, it allows you to actually fire up that DRB port and add data, startup data for your test, and then run a test, which will say, okay, give me all the data centers that I just added. So some of the things that you want to know about this distributed testing tool is that it's based on DRB. It can integrate multiple engines. It can start them up, stop them, collect all the reports, fire tests, tell you what is wrong, like which particular server has an issue, for example. And it allows you to do functional testing. So we could do unit testing with each REST call, but then when we had an integration test which hit a few applications, then this was what helped us. The last thing that we used, another tool that we actually wrote while we were on this project was a cruise monitor. As you can see, we had to deal with so many applications at a time. So we had to keep track of what is going on with the build, making sure that all of them are green. So we had a simple cruise monitor built on Ramaze, another Ruby framework. And what it allowed us to tell is to actually give us instant feedback about what is going on and what has been going on in the past. How good or bad have we been doing with certain applications? So for example, if you see the orange box, that is an application that is building, but if you can look at the history, it has a very small green bar on the top and a very big red bar, meaning it has been failing for the longest, and just recently it has, the performance has improved as far as the build is concerned. So these applications are available on GitHub, and we are soon releasing other open source stuff that we are doing at Rackspace.
So what has been the secret of success, if you see whether we were able to use Ruby effectively in an enterprise? First of all, we did continuous testing and refactoring not just at the code level, but also at the architectural level. We managed the scope and timeline. So instead of having feature-based milestone, we used to have timeline-based. So let us say if you were able to have 10 stories done in, let's say, 2 weeks, we would just do 10 stories. And we wouldn't go and say, hey, let's try to club all 25 stories and release after 6 weeks. Another biggest success, I would say, Ruby, because it allows you to twist and split application. It allows merging domain concept via modularization. It allows also for simple design, and it makes make it simple to make changes. I think there was also another very important aspect which a lot of times people overlook is availability of existing libraries to support enterprise needs. So I have really a very good example on that. We were trying to, like on our IP automation, that was our first project. We wanted to start getting some plugins which does IP. And we went out on OSS and we checked out, oh, there's really a cool suite that which can use. And then finally, we just realized that that was actually written by one of our racker. And it was written about a year back. So, I mean, these are like key things, and Ruby really stands out very well. Now, $1 million question, was this app really written and was it really enterprise ready? I think we really worked hard on that, and we tried to cater to all of these requirements for enterprise. We also tried to support Rackspace growth. But the creme de la creme was when MySQL got bought over by Oracle, and I would say, hoo-hoo, yes, I think, or a lot of people would think that, yes, we are enterprise ready.
So any questions? I know we have been talking about a lot of things, and there's still more we can just talk about this project since it was so long. But if you wanted to know some specific things about how we did it, we can answer those. Yeah, so the question is, what was your favorite thing that you did over the 4 years at Rackspace?
I would say my favorite thing was NDM, because I was involved on NDM from day number one. And it was significant challenge on how to really get it out of market onto production, because Rackspace was very, because just imagine, if you have a bug in NDM, you could bring down the entire Rackspace network with just one click, one wrong click of a button.
Yeah, if you ask me, I would say the one-click connection. So actually, the process used to take, like we said, 4.5 days to actually provision a server. So the customer used to pay on Monday, and his server would be ready on Friday. And when we implemented one-click and it actually brought down the time, we saw the customer as well as our direct report client, the manager. He's like, wow, you can do this. And that was time we partied, actually. So that was actually very nice. I mean, that felt like we had delivered something. Any other questions? Yeah.
Thank you very much for your presentation. So, with Ruby in enterprise development, so what you think the most important feature of Ruby make it suitable for this work?
So it's not just one. There are like many aspects of it. Like I said.
Can you repeat the question?
So the most important aspect of Ruby, why you would choose Ruby on the enterprise and what helped you. So like I said, there are many aspects of Ruby. The key being there is a huge community which helps you build such applications. The maturity of Rails, like everyone in the Ruby world knows Rails or can help you out with issues that if you have. Plus, we have actually interacted with a lot of Rails developers, and they have been really kind in helping us in specific things that we had issues with. Basically, the way Ruby just feels when you write it and when you read it. And we have done this a bunch of times. We have gone to the user and said, oh, what do you want this to do? And he's like, it should do this. It should assign this IP. And we showed him the code, and the code exactly read that. So there is code which says assign IP, update this port, and then save, for example. So that's what the user expected, and that's what he can read. So the communication, there is no barrier to communication between the user and the developer. And Ruby just does it out of the box.
I would also add a little bit to that. Let's say when we had these, when we had, when we needed to have walk away from the finely grained RESTful service and really have richer interface, we had to start using workflow. And I know there were people out there, so-called as architects, they came out, oh, these are really core workflows and that's what you should use. It allows you to drag and drop, but all of our developers, we know that when drag and drop really works out very well in a demo, but when you really want to do a real-life application, it is really difficult. And for example, going out and just checking out root is an awesome workflow. So if you see, like, it's not just one or two things that is good about Ruby, but Ruby is awesome.
Thank you very much. And do I have time to have another question? Is
Yeah.
it okay?
Yeah,
Okay,
you can take one more
thank you.
question.
And on the upside, so with Ruby, so what do you think is the most problem or the not enough about Ruby to do the enterprise development? Do you have any problems such as the performance or something like that?
Yeah, one of the issues that we have been working on, and I think so we are trying to get through that, is we are still stuck on 186 and we are still trying to migrate to 187, and it has been real hard because of our huge code base, like you see, and every time we change one application, we have to make sure the other application changes and stuff like that. So that has been our key challenge right now. So hopefully in the due course of the next year, we'll be able to migrate to somewhere around 1.9, and then some of our issues will go away. Just because we were on the legacy system, we have challenges in going to the latest version and doing the greatest things. But maybe when we have Rails 3 out soon, and we might go to the Rails 3, and that will push us to use 1.9 or something.
Okay, thank you.
Thank you very much.
Arigato.
Thank you. And our next speaker is Jan.